I'm Mohammed Mahin Arafat, and I'll be starting the presentation for our group project. And with me, I have Risalat Amin and Rifat Badhun. For our group project, we have chose blockchain-based voting system with Python as a title. So let's start. First of all, what is blockchain? I think by the time everyone knows what blockchain is and how it works, but I'll still revise the definition. So, a blockchain is a decentralized and distributed public digital ledger that is used to record transactions across many computers so that the record cannot be altered retroactively without alteration of all subsequent blocks and consensus of network. So there are lots of uses of a blockchain, but for our group project we have chose the use of decentralized electronic voting system as one of the very popular use cases of blockchain technology. And compared to conventional voting methods, the electronic voting has increased the process's efficiency and integrity. And because of its flexibility and simplicity to use, and it is in so many terms less expensive than the general elections, electronic voting is commonly getting employed in variety of ways during the election process. For example, there's one country, Germany, and there's Estonia too. They have been trying to adopt this technology. So, why we chose this topic and why it has to be voting system? So, first of all, the blockchain is a digital, decentralized, and encrypted transparent ledger that, when used properly, can withstand the fraud and manipulation. And due to the distributed nature of the blockchain, a blockchain electronic voting system reduces the risk involved with electronic voting and makes voting tamper-proof as possible. And a blockchain based electronic voting system requires a completely distributed voting infrastructure. Only under some circumstances where no single organization, not even the government, has total control over the voting system in the blockchain. And in traditional voting methods, the system centralizes the right to vote. Even sometimes the government or the authority, and nobody knows how to authenticate the document because anyone who wants to change it and replace it, they may do it so fast and easily. And but in the blockchain voting system, there is no central authority in the blockchain based voting system because the data are maintained among several nodes, and it is impossible to hack all the nodes and change the data as a result. And votes cannot be overthrown easily and must be instead confirmed by the tally with the other nodes. And then there is always a possibility even the trusted intermediaries can alter the vote in the traditional voting system, and there is also possibility that with the traditional voting systems intermediaries might take some sort of mistake in calculating the votes with the vote count is not transparent all the time. So this is the reason why we should omit the trust trusted even so-called trusted intermediaries, and because they're questionable. And that's why our blockchain voting system is much more trusted. And this is connected even in the electronic voting system, not the blockchain one. The regular electronic voting system is connected to the internet and has also been tried, and it is already proven that it is suspectable. And we can see in some very big countries, very developed ones, uh, the system was used and it was shown large mistakes after the analysis. For example, we can say Switzerland, in the United States, Washington D.C., and even in Estonia too. And we could see that uh, uh, alarming data reveals were there because they have been targeted by some foreign countries. In Florida, in Illinois, the Russian government has tried to hack the voting registration database. So there is a very big trust issue, right? And that is why we are gonna choose the blockchain. We chose the blockchain and we thought the voting system, if the blockchain is involved, is going to be much more efficient. And then cross-checking with reality. So whenever we are trying to make something new, trying something new, we have to, and especially when we are trying to omit the system which has been getting used for almost 100 year, maybe more than 100 of years, we have to cross check with the reality, because we have to think about the feasibility of the system. And uh, we can see, like, when we talk about the feasibility, we are talking about the system, if it is affordable, if it is scalable, and how easy it is to use. So we should take into account certain criteria or variables to decide whether it is actually practical to replace the current system and be the future structure with use of blockchain based systems technology or not. And it is actually difficult to quantify these qualities globally, because there are some maybe we for example, we can talk about affordability. If we compare it with a system which are traditional, this is obviously much more affordable in some of the countries, because they have already the technologies available, and they know how to work on this one. But for example, like some underdeveloped countries, they do not have all the technologies available, and the hardwares needed, the software needed, or the proper manpower to uh, use all the system. So this affordability part has some gray spot there. I would say it is obviously easier, and it is obviously cheaper than the regular voting system, when it comes to national voting, or or maybe some other voting. But it depends on the context. In some of the countries, this is not very cost effective, but at the same time, it is obviously affordable, and it can be used several times. So it is better than the paper ballots. And then, talking about the scalability, we have to think about the target market, and we have to see if it's supporting all the millions of individuals. We have to think about the security level. It should not be any lower than the alternatives who do not use blockchain technology. And we have to think about the security standards, everything. And then there is one more thing. We have to think about the simplicity of the use. So for example, if we are living in an underdeveloped country or developing country, we will see there is so many people who is not really used to with the technology. So although the blockchain voting system is really simple, but still everyone does not know how to work on a computer, or how to vote, or how to choose something on a computer, because they're not used to with it. And even some of the countries, developed countries, there are senior citizens who are not really using the technology every day, and they're not really used to with that. So we have to think about the simplicity, but it is fairly simple. And I think with just one training session, someone can just know how to choose a voting. It is just like the paper ballot, right? So we have to think about the simplicity of use too. And then there are some prerequisites and risk and issues. So whenever we are talking about uh, any kind of voting system, for example, it can be digital voting machines, it can be traditional ballot papers, it can be internet voting too, or the blockchain voting system too. It has several prerequisites, and it must be made for every type of voting system I talked about. So first of all, the eligibility. Voting should be limited to be the registered voters only. And then there is reusability. Each voter must may only cast one ballot. And then there comes the privacy. Only the voter has to have the access of information about their choices. Then the user experience. Most of the users uh, has to know what they're doing, and has to have the um, familiarity with the system. And then the expense. And if we talk about all these things in the blockchain, we know the eligibility can be done. It is so easy, and it is about the reusability. One person can vote only once, but the whole system can be reused. For example, if you're using one ballot once, it's done, right? You have to recycle the paper or dump the paper and the plastic boxes. So think about all the carbon footprints and all the wastages. For the blockchain system, we do not have this. And mm, if, for example, like if someone is voting somewhere and the election is happening again, or the re-election, he can still use the same technology, same computer, and he can still vote, right? So it is really easy and reusable in terms of, in compared to the paper voting system, the traditional one. And then the privacy. Blockchain is famous for the privacy, right? So it has the privacy, the user experience. We can't talk about this one because we already told, like, not all the users are familiar with the new technologies. That's why the user experience might vary, but it is blockchain can be designed in that way. And then the expense, it is somewhere, I already talked about the expense, so I'll just skip this part. So let's talk about the advantages. First of all, the efficiency and reliability. In a normal voting system, there is in a normal voting system there is a chance to vote being miscalculated, or there might be human errors because someone has to dump all those voting papers in somewhere and they have to count it. It takes time, it can be altered, it can be replaced. And even though I'm thinking everyone is honest and doing their job, there can be miscalculations, there can be human errors, because when there is human involved in a system, especially in the counting and this kind of stuff, there always are human errors. And in the blockchain based voting system, there's no chance of human errors or the miscalculation. Then talk about the transparency. Transparency is the biggest advantages in the voting terms of blockchain, and blockchain is obviously famous for transparency, and we are aware that the lack of transparency might make people doubt the validity of their votes and raise the concerns about frauds and temporary results. A democratic system that is trustworthy has to produce more favorable results in the voting process, so they can use the blockchain to make everything so transparent. And for this reason, it is very crucial that all the records to be correct and preserved securely. And trust can be established at every level of voting process for the blockchain technology, and it is for and its decentralized ledger. Then the security. Security is maybe the most crucial one in the voting related considerations, and voting systems are currently quite vulnerable to hack. The electronic ones, we have seen cases of these ones, and even in the very technologically advanced countries. And then the malicious actors can access the system, change the outcome if there is no strong security measures in the place. And for this kind of stuff, blockchain is very useful in this, because the technology has a capacity to introduce a system that appears impenetrable. And in the system, once the voting is complete, every vote may be checked to make sure it was properly counted. And without blockchain, a centralized organization in charge of the process would have to handle this. And this raises several concerns regarding to reliability of these governing organizations. However, the decentralized ledger system offered by blockchain eliminates the need for potentially corruptible and ineffectively central authority. So I will handle this presentation for my other group members. If I have to talk about the contribution of the group project, I have worked on some terms of front end work in the templates. My friends will be showing the code, and as I was more involved into the research and go through all these research papers and stuff, I would say my contribution was more in terms of research, in terms of research rather than the programming. But I already worked on the basic HTMLs, and my friends who work on the Pythons, they will be showing you the cases. And thank you everyone for the opportunity.
Hello, I'm Rifat Badhon, and I'll talk about the coding section, mainly the backend part. So before I start talking about this, I want to say that we got this project idea from this Git repository, and this was by Adil. And in this project, he basically talked about cryptocurrency and how and about the cryptocurrency transactions. So whenever a user is sending someone else a token, they are using their digital signature, and also it shows about the private and public key generation. So we will use this concept in our project. So this is our Git repository, and we have uploaded our files here. So what we basically did was we took the concept of private key and public keys and digital signatures, and we used that in the voting system. So let's look at the code. And before looking deep dive into the code, let's see how our web pages looks like. So we'll basically have two pages. So one is the blockchain side. So in order to run that, we type Python, name of the file, and we will be running this on port 5000. So if we go there, we will see that page opening up. So I'll not talk about what's happening here. This part will be done by Risalat in the next section. And there is one more page. So we open another terminal, and then similarly we type, and we will be running this on a different server. So let's say 8080, hit enter, and we will see another page opening up. So Risalat will walk you through what's happening here. So let's get into the coding. So first we have the main two files. So this is blockchain.py, and then we have blockchain.client.py. So this is, as we saw on the web page, we had two pages. So this is for the first section, this was the second section. So initially we had to import the relevant libraries from Python. So these are the imported files, and since we took the concept from mining, so since we'll be voting, so we set the reward as 1. So whenever someone's voting, 1 will be sent, and we set the difficulty level to 2. And so we have this class, and this we have blockchain class, and we have this has the following attributes such as transactions and chain. So transaction is it's gonna list the transaction that will be added to the next block, and we have the chain, which is gonna, it is the actual blockchain, which is an array of blocks, and we have nodes. So blockchain will use the nodes to retrieve blockchain data from other nodes, and we have the node ID. This is to identify random node, and we have so this here is the method, so implemented by the following class. So we have register node. So here what happens is that it adds the new blockchain node to the list of nodes, and we have a method named verify transaction signature. So what this does is that it checks that the provided signature corresponds to transaction signed by the public key sender. So, and it takes as input as sender address, signature, and transaction. And we have another method named submit transaction. So here what it does is adds a transaction to list of transactions if the signature is verified, and again it takes as input as sender address, recipient address, value, and signature. And so we have a create block section here. What happens is it adds a block of transaction to the blockchain, and we have a method named hash. So here what happens is that it creates a SHA-256 hash of block, and we have the concept of proof of work. So, and then we also have this method for valid proof. So what it does is it takes an input transaction, last hash, nonce, and difficulty level. So initially, if we see previously we set a difficulty level. So and we have the valid chain. So what is it if a chain is valid? And so we have def resolve conflict. So this one over here, it's basically it resolves conflicts between blockchains nodes by replacing a chain with the longest one in the network. So now this is the Flask part. So here this line over here, it initiates a Python Flask app that we will use to create different APIs to interact with the blockchain, and this line over here is just to instantiate the blockchain. So these are the Flask routerings which we're going to use in our project. And so we have configure transaction new. So here is another so this one's important here. So what this does is this route, this returns all the transactions that will be added to the block, and we also have the chain. So here what happens is the API retains all the blockchain data, and so we have the mining concept here. So this API will return the proof of work algorithm, and it will add the new block of the transaction to the blockchain. So we have a few more routing. So I'll not go through all of them because of time constraint, but these are all routes. And so let's see what we have next. And again, so this is the main file. So here we can see initially I showed you how to run with localhost on port. So here we just set initially for the Python file the port number to 5000. Again, Risalat will go through it again in more details. So this was the for part for the public view where the vote counts we will see on the web page. And so we have this client side page. This is for the client sides only. So this is where the clients will vote and send their vote. So again, we have the import libraries, and so we have this class transactions similarly. So it has the attributes we can see here. And so again, it has the method, so we can see the toDict. So what this does is this method returns a transaction information in a Python directory format, so without the sender's public key. So we have another one named sign transaction. So what this does is this basically, this is the digital signature. And again, we have the Flask and the routings for this part. So I'm not going to go in details. You will see when Risalat goes through the demonstration. Okay, so yeah, so we have on the page you will generate a public and private and public key pair, and it will send the vote to the other page using their digital signature. You will see this in the demonstration page. And again, so we ran initially this page by setting the port to 8080. So we actually have two tabs you will see. So one for the blockchain.py and for the client Pi. So I'll stop my video here and I'll let Risalat continue. So he will walk you through how the thing actually works.
Hello everyone, I'm Risalat Amin. I'm going to demonstrate you our project, but before that I'm going to show you our test file and I'll explain the code of our test files. So here you can see we are using two similar test files for two different folders, for blockchain and blockchain client. So I'm going to explain the code in here. Here you can see this statement, the test API get. So this statement is the part of test API get method, which is one of our test case to test the get method of API under test. Request.get method sends an HTTP GET request to the given URL and returns response object which contains all response data from the GET request and save it to the resp variable. Here, assert is used in PyTest format to put an assertion for a condition. The condition here is to check the response code of the GET request. We can fetch the retrieved response code by using resp status underscore code. Here we are checking if the return response code is 200, and if not, we will print a message for failed assertion. This statement is the part of test API post method, which is a test case to test the post method of API under test. This request post URL data method is used to send an HTTP post request to the given URL which attached JSON data, and response object will be recorded to the resp variable. For running this test file, we have to go to this path and we have to use pytest this command. Enter. We can see it's working and it passed. So this is the testing part for our project. Now I'm going to clear this and I'm going to run two different Python file. One is blockchain.py and another one is blockchain-client.py. So I'm going to enter blockchain client folder and I'm going to run the Python file. I'm going to run this file on port number 8080. Oops, I have to use .py. So it's running. We are going to run another file. So we have to run this blockchain file also in a different terminal. So I have to enter blockchain folder, python blockchain.py, and we are going to run this on port number 5000. So it's running. So this is our front page, and this is the page where voter can provide their vote. So when we click on generate, we can see it's generating a public key and a private key, and for each voter it will generate a unique public and private key. We can choose option from here. So one is Democrat and another one is Republican. So I'm going to choose Democrat first and vote. So here we can see the voter address and vote signature. It's a voter signature. So when we click confirm, it's showing successfully voted using blockchain and added to the next block. So okay. Now we can check it from our front page. So for checking it, we have to mine it. It's a proof of work. So when we click mine, we can see the vote count 1 for Democrat, and here we can see the block is added. It is also showing the time when the voter gave his vote, and here we can see the recipient address is added. Now we can add another vote. So generate. Now I'm going to choose Republican. Vote. Confirm. Now we have to mine it again. So we can see another block is added, and we can see the recipient address is adding to. So that's all from our project demonstration. Thank you.